Alright, this is topic 2.6, looking for proportions within different kinds of problems to see if we can use that relationship to help us solve the problem. And so taking those different steps to understand what's going on. So example 1 took you through those steps. Right, a multi-step problem in the sense that first you had to figure out what the relationship was between the cards and what that ratio ended up looking like, and then double checking to see if it was actually constant, which you found. And then after you found that constant proportion between them, you then also realize that if you divide them both in half, that proportion still remains. And so from there we move on to example 2. So example 2 has us looking for that same idea, but this is the information that it starts with. It says Martin is 6 years old when his sister Cassandra is 3 years old. How old will Martin be when Cassandra is 6 years old? Make a table to find Martin's age. And so by creating this, we understand that if he's 6 now and she's 3, each year they're going to go up 1 to continue going on with their lives, right? You get 1 year older every year. Then with that being said, we start looking for is there a constant multiple? That's the easier way. Instead of jumping right into the k equals yx, we just kind of look for a constant multiple. Is it moving up at the same kind of rate? And initially you would say, okay, yeah, 1, 1, 1. Right? But then you got to think about it, okay, what's the relationship from here to here, from the 6 to the 9? And in that case, we see that it's 1.5. And that's where we do come in and we plug in our numbers, just like they did over here. 3 to 6 is a constant multiple of 2. So by trying to use the equation y equals kx, or k equals x divided by y, we can look for what would be constant. Right? Martin's age, of course, is constant. It's constantly growing in the correct way for Martin. And so, but what we found out was that it was 1.5. Right? 9 divided by 6 gives us our 1.5. On the other side, though, Cassandra has a 6 divided by 3, which shows k equals 2. So these are not proportional because our k's don't match. So in the end, we take this hint, right? We want to look for a constant multiple to determine whether you can use proportional reasoning to solve the problem. Right? In the end, we find out because these numbers don't agree, we would say it is not proportional. Let's move on to example 3. All right, so example 3, even though the book doesn't say it's a video, it is a video. So you get to listen to someone else's voice. But they do a really nice job of explaining how rates can serve as that k for constant, assuming that the rate itself, blah, the rate itself, did you like that blah? Did that make your night? Okay, it didn't. Let's just end this video. Rates can serve as a k for constant because very often a rate remains constant. All right, so get back into Pearson, watch example 3. Once again, if you have questions, put them down on a piece of paper and just ask them, right? It can be a simple question of, can you go through this example again? Can you go through the try it? Questions like that. Or if they're more specific, like I was watching this and he said this idea in the video, whether it was me or whether it was one of these people who created their videos, you can say they made this statement and that was confusing to me. Can you help me understand that statement? So any question like that is going to help you, and usually questions benefit someone else in the room also. And if they don't, then at least it benefited you, and you are more prepared to find success, which is what we're looking for, success for everyone. All right, that's it for to 6.